Welcome to Let's Get to the Marks, going through an equilibrium constant question. Let's get into it.
This time for
Chemistry.
yeah, baby. Yeah.
Question 5. Nitrogen monoxide reacts with chlorine to form nitrosyl chloride, NaCl. The equation for this is 2NO gaseous form plus Cl2 gaseous, reversible symbol 2NoCl gaseous. 5.1, 1.50 moles of nitrogen monoxide are mixed with 1 mole of chlorine, and the mixture is left to reach equilibrium at a given temperature. Now, the equilibrium mixture contains 0.350 mole of NoCl, which is nitrosyl chloride. Calculate the amount in moles of NO and Cl2. They're the reactants in the equilibrium mixture. Now, there's a couple of ways to do this. I like to start by writing out the equation. I know it's a bit of a pain in the bum because the equation's already there, but I write the equation out, and then underneath I draw the little ice board. You might have heard of this before. You write ICE on the left-hand side, and you have a column underneath each of the reactants and each of the products. We've only got one product here. So the ICE, you have I stands for initial moles, C stands for change in moles, and E stands for moles at equilibrium. So my initial moles of nitrogen monoxide is 1.5 and my initial moles of chlorine is 1. What's my initial moles of the nitrosyl chloride? Well, they're a product and there's no products initially, so that is always going to be 0. However, I have been told that the nitrosyl chloride, we've got 0.350 at equilibrium, and that's all my data. So I know that as it's gone from 0 moles to 0.350, the change in moles for NoCl, or nitrosyl chloride, is 0.35. I can now use that change in moles as soon as you've got one of them to look at the ratios between the product and the reactants and work out how much has been changed of the others. So it's a 1-to-1 with the nitrogen monoxide, so that means 0.350 has been used. However, it's a 2-to-1 with the chlorine. So I put the chlorine here in pink. So we've got 0.350 of nitrosyl chloride, but it has a 2-to-1 relationship with the chlorine. So we need to divide it by 2 to find out the moles of chlorine that have changed, and it's 0.175. So all I've got to do to work out the moles at equilibrium is take the initial moles of the chlorine minus the change in moles, so 1 minus 0.175, and I will get the moles of chlorine at equilibrium, and that equals 0.825. There we go, first of the 2 marks. Now we look at the nitrogen monoxide. We had 1.5 moles initially. We know the change was 0.35 because it was 1-to-1 with the nitrosyl oxide. So I do 1.5 minus 0.350, whack it in the calculator, and it gives me 1.15 moles. So that was the change, that was the moles at equilibrium of nitrogen monoxide. So that's the ICE technique. There's various other techniques you can use for equilibria. I have got a couple of other videos. At the end of this video, you'll see I've got some other videos on walkthrough questions. If you want extra practice, you can check them out at the end of this one. So there we go, 2 marks for 5.1. Let's zing on down to 5.2. Give the expression for the equilibrium constant Kc for the reaction between nitrogen monoxide and chlorine to form nitrosyl chloride. Oh my days, I'm going to write the equation out again. So this is just a quick 1 marker. We're just looking to write the expression for Kc in regards to the equation. So I need to put the equation down again. Now, when you're doing Kc, it's always going to be your products over the top of the reactants. So we're going 2NO plus Cl2 goes to 2NoCl. So I want NoCl at the top, and going to use square brackets. Remember, square brackets are for concentration. If you use rounded brackets, they won't give you the mark because rounded brackets is for pressure when you're doing Kp. So we're going to have NoCl, and that is going to be squared to the power of 2 because it has 2 as a coefficient in the equation. And then I'm going to have NO, nitrogen monoxide. Outside the brackets, I'm going to put that to the power of 2 because there's a 2 in the coefficient in the equation, and then times chlorine, which is the reactant, the other reactant. So products over reactants. Let's move on. 5.3 for 4 marks. A different equilibrium mixture is prepared. A different equilibrium mixture is prepared in a flask of volume 800 centimeter cubed at a different temperature. At equilibrium, this mixture contains 0.50 moles of nitrogen monoxide and 0.58 moles of chlorine. For the reaction at this temperature, Kc is equal to 1.32 times 10 to the minus 2 mole per decimeter. Determine the amount in moles of NoCl in this equilibrium mixture. Once again, I'll bust out the Kc expression and the equation because they're going to help me with this. I also need to use the equation N over C times V. Why is that? Because they've given me volume and they've given me moles. So when they do that, I need to convert all of those moles they've given me with the volumes by doing N over V equals C and convert them into concentrations. Those square brackets stand for concentration. Okay, so 0.850, that's the moles of NO, nitrogen monoxide, divided by the decimeters, which is 800 over 1,000. I've just written 0.8, and you get 1.0625. Now, that's moles per decimeter of nitrogen monoxide. And then if we do 0.458 moles of chlorine gas over, or chlorine over 0.8 decimeters, I get 0.5725 mole per decimeter of chlorine. So now I have my concentration of nitrogen monoxide and okay, so let's set this all out as like the Kc expression. So we want to do Kc is 1.32 times 10 to the minus 2. I know that is equal to the product NaCl, which we don't know the moles of yet, over 0.8 moles of NaCl over 0.8 squared. And that is over the top of the reactants, which is 1.0625 squared times 0.5725. So what I need to do is work out how I can isolate NaCl. So how we need to rearrange this, because I can do 1.32 times 10 to the minus 2, multiply it by 1.0625 squared times 0.5725, and that is going to be equal to the products. So as I say, you can keep this all in your calculator. I like to work it all out a little separately, step by step. So 1.32 times 10 to the minus 2 times 1.0625 squared times 0.5725 is equal to NaCl over 0.8 squared. Now, how am I going to get rid of the square sign on the right? Well, first of all, I could actually work out what all my... And this is going to equal 0.00853, which is going to be equal to NaCl over 0.8 squared. Now what do I need to do? I need to get rid of the square. So how am I going to get rid of the square? Well, I can square root both sides. So we're going to zigzag, square root both sides of the equation. That gets rid of the square on the right-hand side. So I'm really doing the square root of 0.00853 is equal to NaCl over 0.8. Oh my gosh, I'm running out of room. And that means I have 0.0926364 is equal to NaCl over 0.8. Now let's get rid of the divided by 0.8. So times both sides by 0.8. And we get our final answer, which is 0.07389. And that is the amount of moles of NaCl. Now, because the 9 is greater than 4, I can round that up to just 0.0739. Or you could do 2 sig fig, 0.074. All right, guys, don't forget, sharing's caring. Hit the like, punch up the bell, subscribe. Let's get to the marks. I'll see you on the next video.
You're still here? It's over.